Okay, so function of the auditory tubes equalize air pressure between inner ear and the outside air. Oops, sorry if you can't hear me. We already did that. um, the bad news, guys, we get these tubes that connect the middle ear to the nasopharynx, and I mean the point of that, they're usually closed by the way, but like they're to swallow to open them up. So like if you swallow or yawn, sometimes the tubes will open. Then that lets the air pressure equalize. Hey guys, so if you're ever like driving in mountains or something like that, like if you ever drive down to Florida and go through Tennessee, like last time we went through there, my ears were popping all the way up and all the way down. So as you go up that mountain, the air pressure on the outside is dropping, and then when you like yawn or whatever, that pop you hear, the tube opened up, and you got that's the only thing. So if you're going up the mountain, the pressure's lower on the outside. As you go up, it's higher on the inside, and the pop you hear is the air rushing out. As you go down on the opposite side, it's the opposite thing going on. But the reason why you keep those kind of closed more often than not is that pathogens can get up in there. So here, right, pathogens can. Oop, they thought I made a web page. Enter middle ear via whatever you want to call them, auditory tubes. Remember, I said whatever you want to call them because you can also call them the eustachian tubes, the pharyngeotympanic tubes. All right, so the bad news: pathogens can enter the middle ear via the auditory tubes. So that's how you can get otitis media. You guys know your itis. Anytime you see that ot, this might be worth writing down. Ot means ear. Ear inflammation middle. So this is a middle ear infection. There are some types, it's inflammation. There are some types of otitis media, or there's a type at least of otitis media that isn't infective. It's called serous otitis media. But it's usually because of germs that are up there. It's an infective disease. What else is good? Oh, here, let's look at some pictures. I googled you guys some stuff. It might be easier for me to kind of move this around. There we go. So this is looking in through. Hey, when your doctor is looking in your ear, in your nose, that thing's called like an otoscope. But if you look in the ear here, you're looking at the tympanic membrane. So over here on where it says normal eardrum, you see that little thing right there? That's the malleus. That's the first ossicle. So the eardrum is it's translucent. You can see through it a little bit, and it's concave. It dips in. And here you can see the otitis media, the ear infection, where it's not see-through. You can see it's kind of light colored. There's probably a lot of like pus and stuff that's accumulating in that. What was this picture? Oh, it's the same sort of thing, but here it says. Remember, I said the tympanic membrane should be concave, and here this is convex. So it says bulging eardrum. You can see it on this. You see all that yellow stuff. That's just there. It says purulent material. Purulent means pus. That's really bad. So the next thing we're going to do is it says tubes in the ears, and here you can see one right there. And it might be kind of hard to get an idea of scale, guys, but that your tympanic membrane, here's where if we were a class, I'd pass the skull around, and you can actually kind of see it. I don't know, tympanic membrane's probably about the size of your ring finger, index fingernail, something like that. So keeping that in mind, you can pretty much guess how big that tube is. It's really small. But you saw how much like pus was in that other eardrum we looked at. You stick that tube in there, and it drains the pus out. It's all like goop. All right, so where'd my notes go? All right, let me move you guys back a little bit. All right, tubes in the ears. So there, the point of that. Instead of typing, I'm gonna cut and paste this. Where are we at here? Tubes in the ears. Check. Drains fluid from the middle ear. That's what you want to put right there. All right, and then the inner ear, deep in temporal bone, about eye level, and nothing to add there. Fine. Contains the semicircular canals and the cochlea. So if you guys, I lost my picture. If you guys don't remember the semicircular canals and the cochlea, there's the cochlea, and we're going to say here in a minute. Anywho, cochlea comes from the Latin word for snail shell. Good name, right? And then here's your semicircular canal. So balance here, hearing here. All right. So let me put it right back. 3. I don't know if I pointed that out. There's 3 semicircular canals. 1 loop, 2 loop, 3 loops. That says one's like in each plane of space. But they're, as it says here, they're fluid-filled tubes And they kind of work like a carpenter's level. It's got like a little cylinder in it with a bubble, and if the bubble's like right in the middle, it's level, and if it's tilted off to one side, your surface isn't level. It's kind of like that. As your head moves around, the fluid in there moves, and there's detectors that pick that up, and kind of let you know how your head's moving in space. Oops, I went way too far. Where am I at? Okay, here. So there's mechanoreceptors in there that respond to that fluid motion. But the function here is to detect angular. This is the main thing you want to go with. I'm not really sure why I said angular, but I guess it is. But it's rotational. So like spinning sort of movement. These guys are really good at picking that up. Like if you do some YouTube vids of people sticking their forehead on a wiffle ball bat and spinning around and veering off in one direction, that's getting picked up by these guys, semicircular canals. Okay, and what we already said a little while ago, so you guys don't have to write anything here. Either receptors respond to movement of fluid in there. Okay, so good, fine. All right, move on. Note, at the base of the semicircular canals are two structures known as the maculae. Oop, hold on, I gotta find you guys a picture. Okay, here's a picture I found. So, it's okay. There's a better one in your book. Again, no clue what page it's on, but here's your see the semicircular canals. There's the cochlea, and then there are these two little red spots right there. So they're kind of in the chunk that hooks them up. That's where the maculae are. But one of them kind of runs, not kind of, totally runs horizontal, and the other one's vertical, so level and straight up and down. And they've got these little, these are the receptors you can see here. And they've got like a jello type fluid, and on top of the jello type fluid are these little rocky things. So it says otoliths. Those literally mean ear rocks. But anyway, you know how jello wiggles and jiggles. So as your head's moving around, it makes that jello wiggle, and these guys pick that up and can kind of tell how your head's moving in space. But these are gonna respond to linear movements, straight forward, straight back, straight up, straight down, sort of stuff. So like if you're in the car and you hit the gas hard, you feel that acceleration, that's being picked up, or you hit the brakes and you stop quickly, that deceleration, you're feeling that with these. And in an elevator, you sense when the elevator stops and stops. Stops and starts. That's straight up and down motion. That's also picked up by these guys, by the straight up and down guys. Okay, so let's go back to wherever the notes are. All right. And I don't think you guys have to add anything to that. So they respond to linear head movements. If what I meant by that wasn't clear, straight forward, straight back, straight up, straight down. Linear means in a line. All right, you guys know of the cochlea. That's where your mechanoreceptors for hearing are at. We've seen it several times, and you guys know I said it like 4 times already. I'll say it a fifth. It's shaped like a snail shell. But so on the inside of the shell, though, isn't a snail. There's something called the spiral organ of Corti. Now this is pretty complicated. I would usually draw like a really simplified picture right here. But I found a decent one. And it's one in your book. Hold on a second. There. Find that picture in your book. So if you look, it's a cross section through the cochlea. You can see there's a bunch of fluid filled chambers in there, and here they're just kind of focusing in on one, and then just zooming in on a part. So if you look, all this is fluid filled, by the way. All those cavities are fluid filled. And then these guys are the receptor cells. They're called hair cells, but because, Jared, check it out, they've got outer hair cells. There's outer and inner, and we're not going to worry about that, but they're called hair cells because they got these little stereocilia that make them look kind of hairy. But those little cilia are embedded in this thing called the tectorial membrane, which is hard. Tectum means roof because it's over the top. But remember, this whole thing's got fluid in it, but that's like hard and solid, and all this other stuff is fluid, and this is kind of a flimsy sort of thing. So as the eardrum gets hit with sound waves, it makes the eardrum shake. The eardrum shakes the ossicles, and then the ossicles, which plug in over there, right there at the window, they shake the cochlea, and as the cochlea shakes, the fluid vibrates back and forth, and that makes these little guys shake. Now remember, this can't move, but this membrane here with the fluid does, and as it shakes, it bends those little hair cells back and forth, those little stereocilia, and then these guys and then somehow or the other, I can't really explain the details to you. Your book does though. These guys will activate that nerve, and then that guy's going to go in. Here it says fibers of the cochlear nerve. That's going to get transduced into another signal that's going to go into your brain, where you'll actually do the perception. Okay, so if we go back to here, you guys don't have to write anything. Again, just look for that picture. But we saw the mechanoreceptors. We saw the little cilia. Um, oh, I didn't. I showed you the tectorial membrane, not the basilar membrane. Go find that picture in your book. The basilar membrane is just the bottom to which the hair cells were attached. And we already said that. Vibrations waves are transmitted from the ossicles via the oval window. And that makes, yeah, okay, we said all that stuff. And the stereocilia detect the movement. Okay, so here it says remember the nerve. It's the I'm going to copy and paste it here. Oops, sorry, too far away probably. It's the vestibulocochlear. Remember what number vestibulocochlear is? If you don't, be sure you do when we take the lecture test, whenever we get around to doing that. Cranial nerve 8. You know what? This bottom part, it's called the vestibulocochlear nerve. So remember on that last picture I showed you, it said cochlear. That's because it's from, there's two different branches. There's a vestibular branch and a cochlear branch, if you want to put that. There you go, vestibular and cochlear. The vestibular does the balance or equilibrium. Cochlear does the hearing. All right, some properties of sound. What is sound? I think I got this for you too. Yes, I do. Hold on just a second. It's compression waves in the air. What is sound? Well, you know, there. Compression waves in the air. You can hear underwater too. So I guess it could be compression waves in any sort of fluid that'll compress, but you know, not in space, right? There's no sound up there. There's nothing to compress in a vacuum. But you know, for us every day, it's compression waves in the air. Okay, so how do frequency and amplitude relate to what sound waves sounds like? We got to do a picture for this. There's a picture in your book that is, oops, not that one, this one. Let me move you over a little bit. This is showing you what a sound wave really is. It's not like an EEG wave. Not really, even though we've got it drawn here like an EEG wave. It's a compression wave. So you got a speaker. So like if you're listening to music, you can feel the speaker head moving back and forth. So when the speaker head moves forward, it rams air up into a high pressure zone. And then it falls back and you got a low pressure zone, and that just keeps on going. So with this picture, I wish it would kind of show you, if you drop a pebble in a pond, you have those, concentric, circles that sort of move out of waves. It's looks like that. It's three-dimensional waves, like spheres that move out. But anyway, you got a high pressure and a low pressure zone, and then that travels. When it smacks your ear, the high pressure zone hits your ear and hits your tympanic membrane and shakes it. But you can graphically represent it as like regular EEG waves. I keep saying EEG waves. Waves that have amplitude and frequency. So over here, all right, frequency. Hey guys, I'm going to try to get this all in this video, so I'm going to pick up the pace a little bit. Here's what you want to write there. Remember, you can pause this if you need to. Oh, there you go. Here, what I just pasted in there, write that in there. Dang it. Okay, here's I paused it so I can just write all the rest of the stuff we need to do. So frequency, make sure you got that. So higher pitch equals, or higher frequency equals a higher pitch, and vice versa. Actually, write that over here. And vice versa. So the faster the waves come, the higher we perceive the actual sound. And there's the range, 20 to 20,000 hertz. That's for a young adult anyway. I'm not quite that good. As we get older, that high end drops off. Amplitude, remember that's how tall the waves are. Long story short, it relates to intensity, so how loud we perceive the sound. And it's measured in decibels. I'm going to pause you again just for a second. I wanted to bring up a decibel scale. So busy city traffic, about 85. Normal conversation, which is probably about what I'm talking right now. I'm probably a little over 60 or 70 decibels. Rock concert, 105 decibels. But if you've ever been to a rock concert, you can kind of feel it as hear it. Those sound waves start to get, compression waves start to get pretty intense there. They really start to smack stuff. Gunshot, 140. I think if you're around sounds that are over 100 decibels, it's long-term exposure could damage hearing. And that's it.